We spend a lot of time thinking about illnesses we can catch from other people. But what about the ones that you can't catch, the ones that kind of build up from the inside? Well, today we're going to pull back the curtain on the science behind these non-communicable diseases. They're some of the biggest health challenges we face, so let's jump right in. I mean, really think about it for a second. You can't get heart disease from a handshake, right? Or diabetes from sharing a water bottle. So if they're not contagious, where in the world do they come from? That is the big mystery we're going to unravel today. So, the official name for these is non-communicable diseases, or NCDs for short. And just like the name says, they're not passed from person to person like a cold or the flu. Nope, these diseases develop from within an individual, usually over a long period of time. But how does that even happen? All right, to really wrap our heads around this, let's zoom in on one of the most well-known NCDs out there, cancer. We're going to take a closer look at what's actually going on at a microscopic cellular level. Okay, so your body is basically a cell-making machine. It's constantly creating new cells to replace old ones. It's a totally normal, healthy process. But cancer is what happens when that process goes haywire. A single cell just stops listening to the rules and starts dividing like crazy, making more and more copies of itself, which eventually pile up into a lump, or what we call a tumor. Now, not all tumors are created equal. You might have a benign tumor, which is basically a lump of cells that stays put. It's not cancerous, and it's generally much less of a worry. A malignant tumor, on the other hand, that's cancer. Its cells have this dangerous ability to break away, travel through your body, and set up new tumors somewhere else. That spreading process is called metastasis, and honestly, that's what makes cancer so incredibly serious. So, if these diseases are starting from within our own cells, what's pulling the strings? What influences whether this happens or not? Well, this brings us to a really important idea, risk factors. This is where we pivot from talking about what a disease is to what actually contributes to it. A risk factor isn't some kind of life sentence. It doesn't mean you're definitely going to get a disease. It's all about probability. It's anything that increases your chances. Could be a habit, could be something in your environment. You can kind of think of it like this. Life is a card game, and risk factors are like cards that stack the deck against your health. But how do scientists figure this stuff out? How do they prove that one thing actually increases the risk of another? This is where the real detective work of science comes into play. Because, just seeing two things happen at the same time isn't enough. You have to prove the connection. And it all starts with this simple idea. Scientists are basically professional pattern finders. They dig through mountains of health data from huge populations, looking for clues and connections that you'd never be able to see on your own. When they spot one of these patterns, it's called a correlation. The classic example is smoking. For decades, scientists saw a clear pattern. As more people started smoking, the number of deaths from lung cancer went up. Then, when smoking rates started to fall, lung cancer deaths eventually started to fall too. That's a super strong correlation. You can't ignore a pattern like that. And here we have the absolute million-dollar question in all of science. Just because two things seem linked, does that really mean one is causing the other? Or could it just be a massive coincidence? To get from correlation to causation, you need more than just a pattern. You need to find the smoking gun. And here it is, the smoking gun. Scientists took a deep dive into cigarette smoke itself. And what did they find? Over 70, that's 70, chemicals that are proven to cause cancer. These things, these carcinogens, can get into your cells and directly damage your DNA. They scramble the instructions that tell a cell when to stop dividing. That was the mechanism. That was the proof that turned a strong correlation into a proven cause. So this whole process, spotting a pattern, finding the mechanism, it goes way beyond just smoking and lung cancer. Let's broaden the investigation and look at how other everyday choices can have a huge impact on our health. Let's actually stick with smoking for just one more second, because it doesn't just go after the lungs. It launches an all-out assault on your heart and blood vessels. It damages the lining of your arteries, the carbon monoxide robs your blood of oxygen, the nicotine makes your heart work way harder than it should, and other chemicals make your blood more likely to clot. It's just the perfect recipe for heart disease. And we see the same kind of clear scientific story with alcohol and the liver. Long-term, heavy drinking follows a really destructive path. First, fat starts building up in the liver. Then, the liver gets inflamed, and for some, it can lead to cirrhosis, which is where the liver gets so scarred up that it can't do its job anymore. And the scary part? that last change is irreversible. And look, this isn't just about smoking and drinking. Scientists have drawn these same kinds of direct lines between all sorts of risk factors and specific diseases. Take obesity and type 2 diabetes. We know that excess body fat can make the body's cells less responsive to insulin. The science on these connections is just crystal clear. These aren't guesses, they're established facts. So what does all this mean in the real world? Well, this is why it matters. This chart shows the leading causes of avoidable deaths in England. And what's at the top of the list? Cancer and cardiovascular disease, the exact NCDs we've been talking about. These aren't just statistics, these are lives that could potentially be saved if we manage these risks better. Okay, so what do we do about all this? This brings us to the final part of our story. And honestly, it's the most hopeful part. Because once you understand the science, you gain the power to fight back, both with treatment and, even more importantly, with prevention. Now, modern medicine is incredible. For heart disease, we have things like stents to prop open blocked arteries, and drugs called statins that are amazing at lowering bad cholesterol. But, and this is a big but, these treatments often have trade-offs. You might have to take a pill for the rest of your life or deal with side effects. And that leads us to maybe the single most important point of this entire explainer. Treatments are absolutely essential when things go wrong. But the most powerful strategy of all is preventing the disease from ever getting a foothold in the first place. So how do we do that? It's not some big secret. The science clearly points to a few fundamental lifestyle choices that can dramatically slash your risk for a whole bunch of NCDs. Think of these as the 4 pillars of prevention: not smoking, watching your alcohol intake, getting regular exercise, and eating a healthy, balanced diet. It's that simple and that powerful. We have covered a ton of ground, from rogue cells all the way to massive population studies. But it all boils down to this. Understanding the science of risk isn't meant to scare you. It's meant to empower you. It gives you the knowledge to make better choices for yourself. So I'll leave you with this question. Knowing what you know now, what's one choice you have control over, starting today?